All right, this is 6.3 part 2, video number 2. So we looked at unit vectors, and now we're going to look at unit vectors that are written in as a linear combination. So when we look at a unit vector that's on a coordinate plane where the how should I say it? One vector. So there's two vectors. One vector is going to be this I1. The x value, right, is 1, and the y value is 0. And then the second component, or second vector, is yeah, they're both vectors anyway. The x value is 0 and the y value is 1. Anyway, and this is what's called a standard vector. And there's two ways to write vectors. Okay, two ways to write vectors. Okay, there's our component form. And that's like 2, 4 with our little brackets, right? Our little greater than, less than looking brackets. And the second way is what's called a linear combination. In a linear combination, that's where we have the I and the J. So 2 will be I, and then it's and then plus 4J. Oops, J, not I again. It's hard to make J's. Okay. Now, so a couple things. Remember, the x value is always the I, and the y value is the J. And then the sign right here, that's going to be based on whatever the sign of this value is. So this is plus 4J because that's 4. Okay. So let's come and just look at some examples. It says, let U be a vector with the initial point 2, -5, and a terminal point of -1, 3. Write U as a linear combination of the standard vectors, the standard unit vectors I and J. So what we would do here is this is vectors U, okay? And we're writing it though in terms of I and J. But again, the I is the x values. So it's going to be negative, and it's the terminal back to the terminal minus the initial. So it's -1 minus 2 I, and it's going to be plus 3 minus a -5, which is basically 3 plus 5, but I'm going to be very specific here. All right, so -1 minus 2 is -3I, and then plus, and then 3 plus 5, since it's 3 minus -5, 3 plus 5 is 8, 8J. All right, so the vector written as a linear combination would be -3I plus 8J. Hey, we can do it again. We'll do it for vector V. Same thing, just it's kind of, it's written different. It says write each vector as a linear combination on the standard unit vectors. I don't know why it's writing, I guess just a different way of saying what we just did. So again, we would do the same thing, that we would go, this is our terminal. So V goes from here to here. So this is initial, and this is terminal. Okay. In the previous problem, they used those two terms, okay, but here it just goes from there to there, so we know which one's initial and which one's terminal. I'm going to change the color up here. Okay, so vector V, same idea though. So we would go 3 minus a -1, which would be the same as 3 plus 1, I, okay, plus -2 minus 5J. Okay, so if we do our math, 3 minus -1, which is 3 plus 1, is 4I. Now here we have -2 minus 5, which is a -7, so this would be a -7J. All right, basic math, folks, basic math. Okay, let's do some other vector operations. So this is the same thing we did with vectors in component form we can do when they're written as linear combinations. So 2u minus 3v. So we're going to write that as like 2 and just a view. So 2 times negative 3i plus 8j, right? And then we're going to go minus 3 times v, which is 2i minus j. Okay, so these values, you realize these values here, okay, are right there, right? Hopefully everybody understands where I'm getting those values, because that's our u and our v. Okay, some people keep having trouble with that. Now we just do our basic distribution. So 2 times negative 3 is negative 6i. 2 times 8 is 16j. And then negative 3 times 2 is negative 6i. And then negative 3 times negative j would be a positive 3j. Now the difference here is that we're going to combine these, right? So we're going to take, we have negative 6i and negative 6i, so it's negative 12i. And then we have 16j plus 3j, so that would be plus 19j. So 2u minus 3v equals this. Again, based on, these are the two standard vectors that we have. And then it asks for the magnitude. We find the magnitude the exact same way it's asking for the magnitude specifically just of u. So magnitude of u equals the square root of, we take the u value, so negative 3 squared plus 8 squared equals square root of 9 plus 64, so equals the square root of 73. So that would be the magnitude. Okay, let's keep going here. Do the indicated operations and sketch. Now we're going to sketch the resultant vector. Okay, so let's first do the operation. I'll do it in green. Oh, we just did green. So let's go w equals 3/2, okay, times just u. We're just looking at u here. So that's 2i minus j. So w equals, let's see, 3/2 times 2i, well, that gives me 3i minus 3/2 j.
Is David up here with you?
He's not.
Oh, okay.
Okay, and then wants us to sketch it. So if we were to sketch it, remember the I is sort of the x value, and the j is sort of the y value. And we would start from the origin. Let's see, we go 1, 2, 3, and this is 1, 2, and 3/2 is basically 1.5, right? So this go 1, 2, 3, and 1.5. And so then we would sketch from the origin to here. All right, so that would be W. All right, so this one. So the vector we want W is going to be, so this is going to be negative of all of this, 2i negative j, and then plus just I plus 2j. So nothing special here. All we're doing is basically multiplying u by negative. So we w equals negative 2i plus j plus I plus 2j. Let's see, negative 2i plus I, that's negative I. And then j plus 2j, this is an I. That's plus 3j. All right, so that would be our answer. Boy, there's a lot here. Let's see if we can zip through these last few. Okay. Oh, this is a little interesting. because it wants us to find the vector v with the given magnitude and the direction. Okay, so this one's a little different. So let's see. What we need to remember when we were doing unit vectors, we were multiplying by, like, 1 over the magnitude, okay, times the vector. And by doing that, we created a unit vector. Well, here we want a vector of magnitude 4. So instead of a unit vector 1, we would do 4, okay? So kind of the same idea. So what we're going to do here is take 4 over what the magnitude of this would be, right? What would be the magnitude of u would be the square root of 2 squared plus negative 3 squared. So we'll just do that. So it's going to be 4 plus 9. So it's going to be 4 over square root of 13. Okay, and then we're going to multiply that. That's like a scalar to each of our pieces of our component. Okay, so hopefully you're following me here. So this leaves us with, so vector, this is vector v, given the direction of u, but with the magnitude. So let me find vector v with the same direction, given the direction of u, this direction, with this magnitude, would equal, we would distribute this through here. So 8 over root 13, oops, this is a vector, so I need to get that in there. And then negative, and again, distribute this here, negative 12 over root 13. And get my, make sure I have my, try to clean this up a little bit. Okay, so we have to kind of use that same concept. So we can do the same thing if it's a linear combination. So we're going to go basically 6 over 6 over the magnitude of u times u is ultimately what we're going to do here. So 6 over the square root of 6 squared plus 1 squared, and then we're going to multiply that by 6i plus j, since that's sort of a linear combination. All right, so this is 30 squared root of 37, okay, times 6i plus j, okay. So our vector, we're going to now just multiply it together. This, we're going to take this scalar, we're going to distribute it in, multiply it into each one of these pieces. So this is going to be 36 square root of 37 I plus 6 over square root of 37 j. All right, it's basic math. It's not nothing fancy here. Okay, so last thing, find linear combination form of the vector given the initial and terminal points. So all we're doing is what we were doing before. We're going to go with 3 minus 0 I plus 6 minus negative 2 j. So 3i plus 8j, and that would give us, didn't tell us what our vector, oh, no, it didn't say, well, call it u. Okay, and same thing over here, just call this vector u equals, you have 0 minus a negative 6. I keep doing this just so you guys understand that we're doing subtraction here, and it's just because it's, anyway, hopefully that's not confusing people. And then 1 minus 4, and that's going to be j, okay? So this is going to equal, let's see, 0 minus a negative 6, that's 6i. And then 1 minus 4 is negative 3, so negative 3j. Okay. Whew, that was a lot.